Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is Vowels Game in a string. In this problem, we have two players, Alice and Bob, and they are playing a game of string. As an input, we are given a string in the problem, and Alice and Bob will take turns playing the following game where Alice will start first. So there is a game which Alice and Bob are playing. We are given an input string S, and Alice and Bob will play the game one after each other. That is, they will take a turn. First Alice will play, then Bob, then Alice, then Bob. Now the game is, when the turn is of Alice, she can remove and she has to remove any non-empty substring from the string S that contains an odd number of vowels, and when it is Bob's turn, he has to remove any non-empty substring from S that contains even number of vowels. The first player who cannot make a move on their turn loses the game, and the main thing to understand is we assume that both Alice and Bob are playing optimally. That is, they will make the best possible move on their turn. We need to return true if Alice wins the game and false if Bob wins the game, right? That is, if Alice loses the game, then Bob wins the game and we have to return false. The English vowels are A, E, I, O, U. Alright, so our input is a string S, and that basically contains lowercase English alphabets. The simple thing to understand here is whenever we have a turn of a player, be it Alice, be it Bob, they will remove a non-empty substring, right, from our given string S. But when it is Alice who is removing it, she will have to remove a substring that contains an odd number of vowels. But when it is Bob's turn, he has to remove a substring that contains even number of vowels. Now try to understand about when a player wins the game. The first player who cannot make a move loses the game, right? So a player can win the game if he can make a move such that the next time when it is the turn of the other player, they cannot make a move. And since Alice is going to start, Alice will have an advantage and she can win the game, right? And we have to return true if Alice wins the game. So it's like saying that our goal is to make Alice wins the game. Now let us try to understand the problem using some examples. Given string S is Leetcoder. This given string S initially contains 1, 2, then 3, then 4. 4 number of vowels. It is E, E, then we have O, then it is E. So it is basically this particular string which contains 4 number of vowels. And the turn is of Alice. Alice is the player who is playing the first time. Can you make Alice win here? Now the simple thing to understand here is we have to remove a non-empty substring, right? We have to remove some substring from the given string S. We can remove the whole substring. We can remove some specific part of the string as a substring, and that's what a player can make a move of. But when it is Alice, she can only remove a substring which can contain odd number of vowels. So she cannot remove the whole string because the whole string is a substring, but it contains even number of vowels, that is 4 number of vowels. So now till 4 we have option of 1 and 3, right? These are the two odd numbers. That is, Alice can remove a substring which contains either 1 number of vowel or 3 number of vowels, right? Now my point here is if Alice will play a optimal turn, her goal will be to make sure that Bob cannot make a move, because if Bob can make a move, then Alice will not be able to win, right? Maybe then she can win in the next turn, but every time the goal is to make sure that the other player cannot make a move, or even if he makes a move, he leaves some space for me so that I can again make a move. So a simple thing to understand here is if Alice removes a substring which contains 3 number of vowels, that is, let us say this is 1, then this is 2, then this is 3. If Alice removes this particular substring, it contains 3 number of vowels, right? It is E, E, T, C, O, right? So the remaining string is L, D, E, R. Now it is the Bob's turn. Now we have 1 number of vowel which is E here, right? So now Alice has made a turn. It's Bob's turn now. Bob can remove a non-empty substring that contains even number of vowels. What are even number of vowels? It contains 0, 2, 4, 6, 8. These many vowels, right? As of now, our string contains only 1 number of vowel, right? So the only option which Bob has is to remove a substring which contains 0 number of vowels. So basically he can remove this L and D, right? He cannot remove a substring which is L, D, E or which contains a E, right? Because then the substring is going to have 1 number of vowel which is odd number of vowel, right? Bob can remove a substring which contains even number of vowels, so maybe he will remove this L and D, and now the string contains 1 number of vowel. Now it is Alice's turn, right? Bob just made a turn. Alice will come and remove the whole string. The string is empty, it contains 0 number of vowels, but now it's Bob's turn. Bob has to remove a non-empty substring, right? But the string is empty, so now Bob cannot make a move and Alice wins the game. So our goal is going to be to empty the string. to remove the whole string, right? If you remove the whole string, the other player will not have a string to remove something, right? And we have to remove a non-empty substring. So the other player will automatically lose because he will not have any string to remove. Now let us try to make some observation. If there are 5 number of vowels in your string initially, and since the first turn is of Alice, she can just remove the whole string because the whole string is a substring, right? If the whole string is a substring, she can just remove the whole string and it will be empty now. And now it is Bob's turn. Now Bob cannot make a move. Similarly, if there is 1 number of vowel, Alice can remove the whole string, right? Because Alice can remove any substring that contains odd number of vowels. So the first observation is, if there is odd number of vowels initially, Alice is definitely going to win the game, right? But what if there is even number of vowels, right? For example 6, or for example when we try to process Leetcoder and it had 4. In this case also, Alice is definitely going to win, and the reason is she can play an optimal game and she can remove a substring that contains 3 number of vowels or 5 number of vowels in case it is 6 number of vowels. That is, she can just remove the whole substring that contains all the vowels except one. That is, in this case, in Leetcoder case, it had 4 number of vowels. She can remove all the vowels from the string except one. So she can just leave the one vowel and she can remove the other substring part which contains 3 number of vowels, right? She can do it. So she will remove it. Similarly, in this case, she can just leave one vowel. Let us say she leaves the E and she will remove the whole substring. So now in this case, what will happen? Again, Bob will have no option to play the game because there is only one character which is a vowel. So from here we understand that Alice is only going to win the game. Bob can never win the game. But there is one chance when Bob can win the game, when initially there is no vowel. If initially there is no vowel, then Alice, who takes the first turn, cannot make a move because what she will remove, right? She needs a vowel, right? Because the minimum number of vowels she can remove is 1. If she removes the substring, it should contain at least one vowel or 3 or 5 or 7 or 9 vowels, right? You have 0 number of vowels. Now Alice cannot remove any substring and she will lose the game. So the only thing we have to make sure is, initially if the string contains a vowel, Bob is going to lose, Alice is going to win. But if it doesn't contain any vowel, then definitely Bob is going to win and Alice is going to lose, right? So simple, what we can do is, we can just first of all create a vowel set which is equal to a set which contains all the vowel A, E, I, O, U, and now run a loop for C in S. If any time your C is in the vowel set, it means your string contains a vowel and you can return true. That is, Alice is going to win. Otherwise, if you are coming out of the loop without returning, so you will have to return false. It means your string doesn't contain any vowel and Bob is going to win. Now you can submit this and this is going to pass all the test cases, and this is a very efficient solution, guys. I would say the time complexity of this is O of n, where n is the number of characters in the string, and the space complexity is O of 1, because we are although using some space, but it is a constant space. We are just using 5 characters, right? It is not a big string or big data we are storing. So yes, we have solved the problem in a very easy way, and that's one perspective of looking into the problem instead of thinking about sliding window. Because initially when I saw the problem, I thought, okay, maybe I need sliding window to count or to keep a track of number of vowels at each point in my string. But then I thought that let's think about from the perspective of a game. When is Alice going to win? When is Bob going to win? And I found that Bob is never going to win if there is a vowel. Alice can just play the game in an optimal way and she will win the game. So guys, I think that's it for this video. If this video has helped you to understand the problem and see the problem in a different perspective, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.